The method of differences. Let f from the natural numbers to the real numbers be a function from the natural numbers to the real numbers. Let ur equal f of r minus f of r plus 1. Then in that case, we have the sum from r equals 1 to n of ur is just equal to f of 1 minus f of n plus 1. And it should be pretty clear why. Because this is equal to u1 plus u2 plus u3 all the way up to un. And by definition of these things, so u1 is f of 1 minus f of 1 plus 1, so minus f of 2. u2 is f of 2 minus f of 3. And u3 is f of 3 minus f of 4. And we're adding these things together, so plus, 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 until finally we get to un, which is f of n minus f of n plus 1. And then we have the cancellations. So f1 minus f of 2 plus f of 2. So those disappear. Minus f3 plus f3. So those disappear. Then there's going to be minus f4 and then plus f4 when we get to the u4 term. So that's going to go away. And similarly, for un minus 1, there's going to be a minus fn in that term. So that's going to cancel with this plus fn. And so we're just left with f of 1 minus f of n plus 1. So if you have some series, the sum from r equals 1 to n of ur, and you can write each of the ur terms in this form for some function f from the naturals to the reals, then it's very quick to sum that series. Now in exercise 3.5, we're asked to show that the sum from r equals 1 to n of this thing here is equal to this thing here. And what a coincidence if we consider, well, if we take the function f of n equals 1 divided by n plus 1, then clearly we can write each of these ur terms as, well, f of r minus f of r plus 1. For example, u1 is equal to f of 1 minus f of 2, which is when r equals 1 in here, because f of 1 is 1 over 2, and f of 2 is 1 over 3, which would be exactly what we get if we put r equals 1 into here. Okay, and so we know that the sum from r equals 1 to n of ur is just equal to f of 1 minus f of n plus 1, which in this case is going to be 1/2 minus f of n plus 1, which would be 1 over n plus 1 plus 1, so n plus 2. And then we can clearly simplify that to n plus 2 minus 2 divided by 2 times n plus 2, which is exactly what it should be. By the way, when you're doing this in the exam, you don't have to go through this whole process of defining some function f and then writing ur terms like this if you don't want to. It's perfectly okay to start writing out the terms and then looking for cancellation that way. So if you got this question in your exam, I doubt you'll get a question that easy, but suppose you did. If you wrote the working out just like this, 1 over 2 minus 1 over 3, and then for r equals 2, it will be plus 1 over 3 minus 1 over 4. And then when you put in r equals 3, it's going to be plus 1 over 4 minus 1 over 5. And then you go plus dot 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 until you get to the nth term, which would be 1. So plus 1 over n plus 1 minus 1 over n plus 2. And then observe that everything cancels. And then that would cancel with whatever was next, and then that would cancel with whatever's before it. So that would be perfectly acceptable working in your exam as well. So you can do these however you prefer. Alright, so exercise 3.6. We have this sum here, and, well, maybe you stare at it for a little while, and then you think, okay, you know what, I can actually write this as partial fractions. So I can use the partial fraction decomposition theorem to get this into 2 terms, and then maybe things will be nice if we do it that way. So the partial fraction decomposition theorem basically tells us that there are going to be constants a and b to make this work. And then from there we rearrange everything. We get 1 is equal to a times r plus 1 plus b times r. And then setting r equal to 0, we get that a is equal to 1. And then setting r equal to negative 1, we get that b is equal to negative 1. And so that is very convenient, because then this is the sum from r equals 1 to n of 1 divided by r minus 1 divided by r plus 1. And clearly that's of the form f of r minus f of r plus 1, where we take f of r to be the function 1 divided by r. And so we know that this sum is clearly equal to f of 1 minus f of n plus 1, which is going to be just 1 over 1, which is 1, minus 1 divided by n plus 1. And that is equal to n divided by n plus 1. Okay, and then it says, hence find the sum from r equals 1 to 10 of 1 divided by r times r plus 1. And so clearly that's equal to 10 divided by 10 plus 1, so 10 over 11. And then I wrote here to 6 decimal places. I think I was trying to be funny when I made that ages ago. Well, let's just do it. It turns out it's equal to 0.909 and then 091. 1, 2, 3, 4, 5, 6 decimal places.